Hello everyone. The term vector is used to indicate a quantity, such as displacement or velocity or force, that has both magnitude and direction. Okay. So what is magnitude? A vector is often represented by an arrow or a directed line segment. The length of the arrow represents the magnitude of the vector, and given by this notation. This is the magnitude of the vector v, and let's say the components of the vector v are a1, a2 and a3, and the magnitude is equal to a1 square plus a2 square plus a3 square, and square root of this. So this formula gives the magnitude of a vector. So what is vector field now? I think you are familiar with the addition and multiplication of vectors. So a vector field is a function that associates a unique vector f of p with each point p in a region of 2 or 3 dimensional space. The standard notation for the vector field f of p in 3-dimensional space is given by this formula. Okay. What about in 2-dimensional space? If you work in 2-dimensional space, the vector field f is equal to f of xy, of course. We don't have z anymore. F of xy is equal to, the vector field is equal to f of xy I component plus g of xy y component j component. Okay, so it is a vector field in 2-dimensional space. We have some samples, some examples of vector fields in 2-dimensional spaces. As you see, if you have a constant vector field, you may have something like this. If you have a shrinking radial field, you may have something like this. For the unit tangential field, you have something like this. If you work in 3-dimensional space, I give 2 examples for 3-dimensional space of vector fields. What is actually a vector field? As you know from calculus 1 and also calculus 2, we are very familiar with the functions of 1 and 2 variables. For instance, we know that they are machines, they have some inputs and they have some outputs. Okay? Let's remember the function of one variable. For instance, let's say you have a machine. I mentioned about this before. This is the function. If you have f of x, it means you have an output x, an input x, then output y. That is f of x. Okay? So, if you are in 2-dimensional space, it means that your function has 2 inputs instead of one input, 2 inputs, x and y, and still has one output. Z is equal to f of xy. It is the idea of the function of 2 variables. What about the vector field? You have capital F. Okay, you have capital F. Let me put a row on the top. So for this, you may have, if you work on 2-dimensional space, you have 2 inputs. If you work on 3-dimensional space, you have 3 inputs. Let's say we have 2 inputs, x and y. Let me clear this. Let's say we have x and y. Okay, x and y as 2 outputs, 2 inputs. What about the outputs of the function? of the vector field function f. So vector field generates what? Vector field generates vectors. Okay, so for the first one, for the first component of the vector is what? F of f of the first component of the vector is f of xy. Okay, and the second component is g of xy. Okay, it's the idea of vector field. Vector field generates functions of vectors. Okay, so let's look at this example. A vector field on R square means you work on two-dimensional space. So with the vector field f is given. Okay, is given here. So the question is that describe the vector field by sketching some of the vectors. Okay, as I told you, this vector field gives us some vectors. Okay, for instance, for the point 1, 1, I will compute each of them. For the point 1, 1, how do I get? We have minus y, as you see, minus y I plus x j. Okay, so we have 1 for y, 1 for x. So it means for y, for minus y, you have minus 1 I, that is minus I. Okay, plus for x equals 1, you have 1 times j, that is j. So it means, in other words, it means you have minus 1, 1 vector. Okay, so at the point 1, 1, this vector field generates the vector minus 1, 1. Okay, again, at the point 1, 1, this vector field generates the vector minus 1, 1. Okay, at the point, for instance, 1 minus 1, this vector field generates the vector what? You have minus 1 for y, so minus 1 is equal to 1, that is you have I. Since x is equal to 1, you have plus j, so it means you have 1, 1 vector. Okay, again, for the point 1 minus 1, this vector field generates the vector 1, 1. What about the point minus 1, 1? They are all arbitrary points. You may choose some other points. For instance, what about at the point 5, 10? What about at the point 7? What about at the point minus 10 and 5? Okay, you can generate the vector field at each points. Okay, so I arbitrarily choose that function, that points. So what about at the point minus 1, 1? At the point minus 1, 1, since y is 1, then you have minus I, that is minus y. Since x is also minus 1, you have minus j. So in this case, your vector becomes minus 1, minus 1. Okay. At the point, for instance, minus 1, minus 1, this vector field generates the vector I minus j, that is 1 minus 1. Okay, and finally you are free to choose anyone. Let's say, let's look at the vector field at the point 2, minus 3, for instance. Okay, let's look at the vector field. We have minus y I plus xj. Minus y means you have 3 minus minus plus I plus xj means you have 2j. Okay, so this is the vector at the point what? At the point 2 minus 3. Okay, so the next step is to sketch all these vectors for the given points. Okay, let me clear. I want to sketch the vector field at the given points. Okay, so let's have a two-dimensional space, two-dimensional coordinate xy. Okay, so at the point 1 1, is the first point to check. 1, let's say this is 1, this is 1, 1 1. Okay, at the point 1 1, so the vector field generates the vector minus 1 and 1. What does it mean, minus 1 and 1? 1 unit left, 1 unit up. So 1 unit left, 1 unit up, something like this. So this is A. Okay, 1 unit left, 1 unit up. For the point B, for the point B, we have 1 1, we have the vector 1 1 at the point 1 minus 1. At the point 1 minus 1, this is minus 1. This is the point 1 minus 1. At the point 1 minus 1, we have 1 1. What does it mean? What does it mean, the vector 1 1? 1 unit right, 1 unit up. 1 unit right, 1 unit up. Okay, something like this. So let's look at, this is B, this is B. Let's look at the point C. At the point minus 1 and 1, at the point minus 1, now we have minus 1 here. At the point minus 1 and 1, this is the point minus 1 and 1. Okay, at this point the vector field generates the vector minus 1 and minus 1 minus 1. What does it mean, minus 1 minus 1? 1 unit left, 1 unit down. 1 unit left, 1 unit down. 1 unit left, 1 unit down. Okay, something like this. So this is C. Okay, this is the vector C. Let's look at D. At the point minus 1, at the point minus 1, this is the point minus 1, right? This is the point minus 1. This is the point minus 1. At this point, the vector field generates the vector minus 1 minus 1. What does it mean again? Minus 1 vector means 1 unit left, 1 unit down. 1 unit left, 1 unit left, 1 unit down. Is it true that we have minus 1 vector for the point minus 1? No, it's not right. So the right version is given here. Okay, this is the vector field at the point minus 1 minus 1. So if we have 1 unit right, so the vector D becomes 1 unit right, 1 unit down, 1 unit right, 1 unit down. Okay, this is D. It seems this is not true. Okay, let's look at the last point. For the point O2, the vector field generates the vector minus 2O. Okay, minus 2O means 2 units left and don't go to up or down. Okay, so at the point O2 means you are here, this is the point 2. Okay, at the point O2 the vector field generates minus 2O, means 2 units left, only 2 units left. This is the vector E. Okay, of course they are all vectors and they must have rows. So I think this is a nice example to understand the idea of vector field. Now I want to give another example. Sketch the vector field F. Sketch the vector field F of x, y, z, which is given by zk. Okay, so let's sketch this vector field. Let's see this vector field generates what kind of vectors. Okay, do you have any idea? So it means for each z you have a vector. Okay, for each point, what do I mean? For instance, for the point 0, 0, 0, you have this vector. Okay, for the point, for instance, 0, 1, you have this vector. Okay, what does it mean? It means you have 0, 0, 0. Okay, you have 0, 0 and 1. Okay, for the point, for instance, let's say 1, 0, 1, you have again 1k, the same vector. Okay, so actually this vector field generates the constant vectors. So I think it's enough for the time being, but I want to remind you that this idea is very important, especially when we focus on the line integrals. So it is the must component of the line integrals.